Hi, welcome back to another episode of Algebra and Words for YouTube. We're going to continue our discussion with linear equations. And one of the important things that you need to learn along with linear equations is slope. So we're going to start going over slope, and let's take a look at what I have on the board. I have a few things. At the top I have two generic points, which I call x1, y1, and another point x2, y2. I would say that this represents some arbitrary point 1, and this represents point 2. Alright, we'll look back at them in a second. Then let's look at slope, what it is, ultimately the formula, and how to calculate it. So I like to usually write it like this. M represents slope in the equation. M is slope. What is slope? Some refer to it as the rise over run. Okay? And I also translated it to the vertical change over the horizontal change. Sometimes you may hear it as the change in y over the change in x. When you hear the change in something, usually the way that you find that is by subtracting the former minus the latter. Or you could think of it as y2 minus y1 over x2 minus x1 equals m. Okay, now, suppose you're given 2 points, and we're going to look at 2 real points shortly, but I have 2 generic points here. What I want to say about this is, it doesn't matter which one is point 1 or which one is point 2. If you're dealing with random points on a graph or in a textbook, you just assign which one you want to count for point 1 and point 2. Once you do that, all you have to do is be consistent with which ones are which. So for example, if you decide that this is point 1, then this has to be y1 and this has to be x1, and they have to be associated with each other. So the same numbers go into this formula properly. y2 minus y1 over x2 minus x1. Once you put those numbers in, you get a number for m. It might be a whole number. It might be a fraction. If it's a fraction, I recommend leaving it in fraction form for now. Could it be a decimal? Yes, I would leave it in fraction form. That's the best case scenario. Okay, so once you calculate m, where does m go? Well, it could go into 2 equations. It could go in here, in the slope-intercept form. It can also go into here, for m, the point-slope formula. So I'm going to pause the video, and we're going to do a couple practice problems for slope. Okay, so I put 4 sets of points on the board. All we're going to do is use the 2 points given to calculate slope for each set of points that represent a line. Okay? And we are going to analyze it a little step deeper so that we get the full picture on everything that's here. So let's start with this set of points, which is 5, 10, and 6, 5. Alright? All we're going to do is substitute these into the formula for slope. Okay? And just for consistency, let's assume that the points on the left are point 1 and the points on the right are point 2. So all we have to do is plug in properly. Okay? What I also want to say is just make sure you watch your signs and make sure that you put the proper negatives in where they go, and if there needs to be conversions from negative to positive due to a double negative, we'll be sure to do that. So let's write m, and of these, what is y2? That would be 5. I'm going to write 5 minus y1, which is 10, over x2, 6, minus x1, 5. Let's just simplify. In the top, 5 minus 10 is negative 5. In the bottom, 6 minus 5 is going to be 1. So we could reduce that to negative 5 if you want. Since this represents slope, I usually tell my students leave it in fraction form even though there's a 1 in the bottom, because when you have to plot slope, I think seeing the 1 in the denominator just reminds you that you need to move move your pencil 1 unit to the right if you're plotting it. So I'm going to circle this, and that problem is pretty much done. Let's look at the next problem. Once again, I'm writing m equals, what is y2? it's negative 7. Minus y1, which is negative 5. Notice this is negative, so that goes here. This is minus, but this is also negative, so I'm going to put that minus 5 in parentheses. And we'll deal with the double negative in a second. Over x2, which is 2, minus x1, which is negative 6. So we're going to have minus negative 6. And let's simplify. All right? Minus on minus is plus, so negative 7 plus 5 is going to be negative 2. And minus on minus of 6 makes plus 6. 2 plus 6 is 8. Okay, it isn't a fraction. That is okay, but you do want your fractions to be reduced. So let's reduce this to negative 1 over 4. Negative 1 over 4. All right, let's go to the next one. Right here. M equals, and what is y2? Negative 1. Minus y1, which is also negative 1. So we have minus negative 1 over x2, which is negative 7, minus, this is positive 5 for x1. We just put in 5. Let's simplify in the top. Well, we have negative 1 minus a minus 1, which is like negative 1 plus 1. Negative 1 plus 1 is 0. And in the bottom, negative 7 minus 5 is negative 12. Now, what is 0 divided by any number with the exception of 0? It's 0. So the slope is 0. We'll come back to that aspect in a few seconds. Let's do the last one. M equals 7 is y2 minus y1, which is 5. And in the bottom, y2 is this negative 1 minus this negative 1. Simplifying the top, 7 minus 5 is 2. And in the bottom, 1 minus a minus 1, which is plus 1, is going to be 0. What is 2 divided by 0, or any number divided by 0? It's undefined. So when finding slope, okay, if we go over the 4 answers, we have negative 5 over 1. You could write it as just negative 5. I like to keep it over 1, especially for beginners. Then the next one we have negative 1/4. Okay, if I were to ask you what is the trend of those slopes, it would be down. It would be, the sign of it is negative, meaning that the trend of the linear equation goes down and to the right. But let's look at a couple more details here, because this and this, the top two ones, are for diagonal lines. But what about when you have a slope of 0? What does that mean? Slope of 0 is for any horizontal line. So right next to it, I'm just writing, abbreviating for horizontal line. You should automatically connect the slope of 0 with horizontal line, or if you have any horizontal line and you're asked what's the slope, you automatically say 0. Okay? You can calculate it if you're not sure what it is, and then you calculate it and get to 0. But let's say that we only had the points, and let's go back in time for a second before we calculate it, and let's look at some details. So when we look at these points, which we now know in retrospect are going to be a horizontal line, slope of 0, just stare at those points for a second, and what do you notice? Well, you should notice that the y portion is the same for both. It's both negative 1. Okay? If I were to ask you what's the equation of the line just by looking at these 2 points, since the y values are the same, that means that they're the same for every point. You could write the equation for that as, I'm just going to squeeze it in here, y equals negative 1. Okay, and Do all those details make sense when you tie them all together? Yes. A y equals a number is a horizontal line, and a horizontal line always has a slope of 0, which we proved by calculating, but we also sort of proved just by looking at the fact that the y values of both points had the same number. So that's a telltale sign. On that note, let's go to the last one. Okay, we have a slope of undefined. Okay, is that legitimate? Is that real? Can you have this slope of undefined? Yes. Okay, and you should always associate a slope of undefined with a vertical line. But besides that, it's also important that I always tell my students, it's very easy to, but make sure you don't confuse and mix undefined with the same as 0, okay? Because they're actually different. Undefined is, all I could say to you is that when you think of it in general terms, 0 and undefined, you could think of them as the same thing, but you shouldn't think of them as the same thing because they're different. That's pretty much all I want to say about that, is to not confuse them. But let's take a look at the points. Okay, stare at those points for 2 seconds. Do you notice anything that stands out? Hopefully the fact that the x1 and the x2, both x values for both points are the same, -1. Alright, that's a telltale sign. When the x values are the same, you're going to have a vertical line. Could we figure out what the equation of that vertical line is just from these points? Yes, we could say, I'll squeeze it here, x equals -1. I don't know if that gets cut off on the bottom of the screen, but I can tell you it's just x equals -1. Alright, and that's for a vertical line, which we say has an undefined slope. If you were asked a question like that, you would just write undefined. If you were to calculate it on your calculator, a number divided by 0 will give you error. So that's pretty much it for this video. I just wanted to take it a step further with delving into slope, and we'll use slope and just take this a little further in the next video. So thanks for watching. I hope this was helpful. If it was, please give it a thumbs up and please share with your friends. Please also subscribe to the channel so that you can get alerted to any updates as they come, and I should be making more shortly. So anyway, see you next time.